Okay, everybody, we're moving on to lesson number 8. Hopefully, going through lesson 7, you know the general shapes of a polynomial graph. For instance, if you look at this graph that we have here, you would tell me that that is an odd degree because the arms are in different directions, and the leading coefficient would be positive because the right arm is up. Okay? So, and this is actually the equation of the graph. Okay? X plus 1, which gives us the 0 of -1 right there, and x minus 3, which gives us a 0 or an x-intercept of 3. But this one has this little 2 here, and we have this little bounce here. Okay, so this is what we're going to study in this lesson. These exponents on each of the factors are called multiplicities. Okay, so when somebody talks about multiplicity, talking about the exponent on the factor. If the factor is x minus a, that's b. This is the multiplicity. All right, and then going back here for a sec, to figure out the degree of this function, add the multiplicities. So if that's a 1, n plus 2 is equal to 3. And that is my degree, okay, which matches what we predicted with the odd degree and positive leading coefficient. That's up, and we know it's positive because there is no number in front. Well, there's a 1, positive 1 in front of the x plus 1. Okay, so there's two types of multiplicities. There's even multiplicity. So that is going to be to the power of 2 or 4 or 6 or any even number. When you have that, it's called you have a tangent at that 0. What happens is the graph comes down and it bounces. Now the reasons for that, we're not going to go into here. All you need to know is that it will hit the graph and bounce off, okay? So even multiplicities give you a tangent or a bounce. I don't really care what you call it. Understand that it is called a tangent, but if you say bounce, I'm not too worried. The other type is you have points of inflection. So these are odd multiplicities. So obviously, some bracket and 3, 5, 7, ... Not 1. Not 1. The multiplicity is 1. Go back up here for a sec. Like this x plus 1 here, the graph just passes right through. Okay. If it's any other multiplicity, 3, 5, 7, odd, you get what's called a point of inflection, which we're going to simplify as a POI. Now, what that actually means is the concavity of the graph changes. We don't study concavity in this graph, or in this course, sorry. So you don't need to worry about that. You study it in calculus a lot more. But what it means is the curvature of the graph, and you can see this part of the graph is curving down, whereas this part of the graph is curving up. Okay. Yeah, and the point at which it changes, which is right there, is your point of inflection. Okay. Again, we don't worry about concavity. Just know that a point of inflection occurs when you have an odd multiplicity. All right, so here's our first polynomial. A big long thing. They have factored it for us. Because we have it factored, we know the zeros. So first bracket, you're going to get -3 as your x-intercept, and then -1, and then you're going to get 2. The degree of this is what? Actually, yeah, what's the degree of this? Add the multiplicities. 1, 2, and 3. 1 plus 2 is 3, 3 plus 3 is 6. So it's degree 6. The leading coefficient of this is going to be positive. So If the leading coefficient is positive and the degree is even, that would tell you both arms are up. So we would start on the left, arm up, we come down. What happens at 3? Okay, there's a multiplicity of 1. That means we pass right through. Graph turns around at -1. We have a multiplicity of 2, so the tangent, it bounces. And then we come to 2, it has a multiplicity of 3, which means you have a point of inflection. So I'm going to exaggerate it. It does this little flattening out thing here. It only hits the graph once. If you zoomed in on it, I'll show you on Desmos in a sec here. If you zoom in, it actually only hits the graph once. But this is your point of inflection. If you're sketching the graph and you want me to truly understand that that is a point of inflection, just write POI. This is your tangent. What's that number there, people? -24. Remember, the y-intercept is always your constant term. All right, so we can fill in this little table here. So we have 3 zeros. We have -3, -1, and 2. -3 is a multiplicity of 1. -1 is a multiplicity of 2, and 2 has a multiplicity of 3. This passes through the graph for the x-intercept. This is a bounce or a tangent right there. And this is a POI, point of inflection. And again, to get the degree, add the multiplicities together, 5, 6. And the sum of the multiplicities is 6. So they're just kind of confirming that these are the same numbers. Okay. Let's look at, actually, yeah, let's go to Desmos for 1 sec here. I'm just going to show a standard POI. So I'm just going to do x times plus 2 bracket. That's the thing. Now we can write our functions in factored form to get whatever graph we want. X minus 2 bracket, and I can change the multiplicity to 2, and you can see when I wrote x minus 2, I'm getting a tangent at that point. X plus 2, which gives us a 0, -2, goes straight through. If I want to show what a point of inflection looks like, I can just go x minus 5 and raise it to a odd, so I'll just say 5. And you can see here at 5, there we go, you get the point of inflection, and it looks like it flattens out. If you actually zoom in on it, it only hits the graph at one point at that point, even though it looks like it's flat. Okay, we just don't have the resolution to see it, but it only hits the graph at one point. Okay, where's the graph? All right, back to our lesson. So go to the bottom here. Here's our polynomial. I'm just going to tell you what it is in factored form. You guys can punch it in Desmos if you wanted. X plus 4, x minus 4, x plus 1, all squared. That's what it is in factored form. Okay, so what are my zeros? We have -4, +4, -1. What are my multiplicities? -4 is 1, +4 is 1, and -1 is 2. So before we draw this, we can figure out what it's going to look like. We have a multiplicity of 1, we pass through the x-intercept. 1 again, so that's going to be the same. 2 is a tangent, or a bounce. Okay, what is the degree of this polynomial? 2 plus 1 is 4. The sum of the multiplicities is 4, blah, blah, blah. So we mark our zeros. -4, 1, positive 4. We have an even degree, 4, leading coefficient that is positive. So both arms are up. A -4 with a multiplicity of 1, so it passes through. At 1, oh, I drew it wrong. That should be -1. So let's fix that. Those of you that caught it, good on you. You wrote -1 there. So it should be -1 there. There we go. Let's come down at -1. It's a multiplicity of 2. So it's a tangent, and it bounces. And then at +4, multiplicity of 1. So it just goes on forever, up. Anybody tell me what that number there is? The y-intercept? -16. Okay, and that actually helps you determine if you drew the graph right, because you'd have to have both arms up, and it should go through a point that is below the 0, which is a negative number, which works out. All right, I'm going to go through one of the questions with you, but here's the list of what I would like you to do. That's it for this lesson, very short. Oh, sorry. Yeah, that's it. We are doing number 5A, J, and 7 to 12. And you can check your answers with Desmos. We are it's just getting used to what the graphs look like. A little more detail now. We look at tangents, point of inflection, etc. But let's do one of these together. So number 5. A cubic polynomial. This is a general form. The leading coefficient of 1 has zeros that are this, and this. Okay. So -6, mark our zeros. -6, 1, 1, and 3. Yes, graph, right. Okay, so it's got 3 zeros. It has to be leading coefficient is +1, and we are odd degree, so that means our right arm is up here somewhere, and our left arm starts down. So we come up. They don't say anything about the multiplicities. If they don't say anything about the multiplicities, assume it is 1. So it goes up, turns, which means it's passing through each one. And that's what our graph, that's really ugly, but it works. And then to write it in factored form, all you have to do is go. That's all I want you to do is write it in factored form. That's all the curve blah. Just write it in factored form. It's going to be x plus 6 minus 1 minus 3. And if you want to know what your y-intercept was, you would just multiply the constant terms. 6 and 3 give me positive 18, which makes sense because we are above the x-axis. All right, I'll do one more. I'll do 6, and then you guys are on your own. Again, cubic polynomial. Co-leading coefficient of +1. Function has 2 zeros. The 0, 2, okay, which means 0, 2 has a multiplicity of 1. So what that means is, if I write it in factored form, it's going to be x minus 2 and has a multiplicity of 1. And the 0 of -3 has a multiplicity of 2. That would be x plus 3 has a multiplicity of 2. You're going to sketch this graph. The degree is 3, and the leading coefficient +1. So we know if it's positive leading coefficient, our right arm has to end up. since it's an odd degree, we start down here because they go in opposite directions. So the graph comes up at -3. We have a multiplicity of 2, which means we have a tangent. And it turns, and it goes up like that because it passes right through the multiplicity of 1 at 2. If you want to know your y-intercept, -2 times 3 is -6. All right, I hope that makes sense. Email me if you have any questions. Oh, and just for these ones, I just wanted you to do a quick sketch. They've already given it to you in factored form, so you just really have to practice sketching. That's all I'm looking for here. Okay. Thank you and good luck.